This is Ray's Magnetic Torque Generator 5. I have a setup here, and you can see how I have this set up here. That's the magnet. We'll have the diagram later. This is my flapper. It has a magnet that flaps. It is hooked, connected to a small generator, which is connected to 5 lights. Each one has 9 LEDs, so that's a total of 45 LEDs. Okay, my operation here is trying to show that I have more power out than power in. I have my ounce gauge, and I'll move it out of firing position, and you can see it's just very little, a little bit of drag and so forth like that. But you can see that this is what I call my input. It has very little. Okay, put that back in the firing position. I have this in a equilibrium between the flapper and my magnet on my base. Okay, so what I'm going to do now, that's what I called my input. Let's see what kind of output I get from that small bit of input power. So here's my generator. I have it where it's on equilibrium. A small push to bring it out of equilibrium, and that'll fire my generator, which hopefully that'll do something with the lights. Now remember, there is a physics law that action has an equal and opposite reaction to it. So I would assume that my action that I put in to putting it into equilibrium is going to be about the same as my reaction, which will be very small, I imagine. So let's see what happens. I'm going to bring it out of equilibrium. It probably won't fire because equal and opposite reactions. So here's the reaction, and it probably won't be much. So let's just see. It lit all 45 LEDs. Now that was, let me just manually put this back. If you want to see that fire, I'll go ahead and fire it there. See how that brings it up to the firing position. So let me bring that back. So the input again, we used the ounce gauge, very minimal, and yet we're able to fire 45 LEDs. Now, what is the force that is being presented by that magnet, the flapper? So let's go ahead and I'll bring it back. I'll push it back, and we'll see what happens. So there's 2 ounces already. That's more than what we had. There's 4 ounces. That's good. 4. There's 6. 7. Almost 8. So call that about 8. Four. So remember, the force that was needed wasn't much at all. So we'll call that about 8. Okay. So how much is that? Around 8 ounces. That's close to half a pound. Okay. I'm going to have this weighed about an ounce or so. About an ounce. Okay. Let's see. I have several quarters here. Here's 5 in each one. Let's put 10 in there. Let's see how many quarters 10 quarters would be for the weight. We're about, what, 5? 3? That's about 3. It's about 3 ounces there. Okay, let's go ahead. So that was 3 of those, so that was 15. There's 20. 25. 25 quarters. Let's see how much 25 quarters weighs. What do we got there? We're coming. That's about 5. Okay. Hope I'm reading that right. Okay. So I've got 25, 30. I think that comes out to 40. I'm going from what I did earlier. So that's about 40 of those quarters. So there's about 8, but we had an ounce from the small cup, so really we can go up to say where it says 9. So there's 45, I think. So we go up here. That's a lot of quarters. That's a lot of force from, if you remember our input, what I was just really didn't even hardly register on my gauge. So there's about 9. So that's really 8. So there's close to 40, 45, the weight of that many quarters was in this firing. So when we see that firing like that, we have the weight of 40, 45 quarters. So I think that's pretty extraordinary because, if you remember right, this was very, very little when we were rotating it. Get out of these lights down there. So if you remember that this will self-reset itself as we go around. Okay. And they're fired by itself. Now we're going to set it up on my motor here. Okay. Okay, let's put my... Okay. I have equilibrium, so I'm going to bump this up just a hair so it fires on itself every time it comes around. I have to give it a little bump to reset it here. Okay, come back here. This is so you can see what's going on here. Just a bump to bring that back into place there. There you go. I'm manually resetting it because it's just doesn't take much, but it's just worse not doing it on its own. So you can see what's going on here. I have small input, but a greater output. So, of course, you can make up your own mind. So, what's happening here, the law that says for every action there is an equal and opposite reaction, well, these bars, let me turn this off, are magnetically neutral. I have a screwdriver here, iron, and if this was magnetic, it would stick to it. I'm staying away from the magnet because if it reaches over and grabs my screwdriver with one hand on the camera, I can't disengage it. But you can see how that's neutralized. And yet it's saying for every action there is an equal and opposite reaction. Where is that reaction force? It doesn't seem to be anything reaction. I call this active and non-active. Right now it's non-active. Why is it non-active? Well, the iron bars are neutral. In principle, when there is a sufficient coverage of a north-south field, which is the fields on the north and the south on the other end, well, in between those is a north-south barrier. So I'm having that covered with a iron bar. So according to the principle, which I made up, the iron bars are magnetically neutral when there is sufficient coverage. I'm covering those with a magnetic iron bar. The resultant magnetic field within the iron bar is zero. One can say it is like one is plus and one is the other is minus, and the sum is zero. Like a tug of war, the rope goes nowhere, even though both forces are present. The action and reactive forces, they're still there, but they're into a neutralization between themselves, and there's no breaking of laws of physics. And they're reacting upon themselves. That's what it is. And so you have a neutral magnetically bar. So that allows my input forces, my magnet forces, to come in and out of firing positions and so forth without very, very little input. So I'm not breaking any of the laws. So let's go ahead. I think we covered this here. This is my flapper. It's a 1/4 inch by 1 inch by 1 inch Neo magnet. And it's about 45-degree firing. I have a small stop that stops it in about a 45-degree position. So we'll go ahead and start this up one more time. Okay. Yep. It's just right on that mark. Let me push it just a little closer. There we go. I'm helping it reset a little bit because it's just right on that borderline. You can see there's not much to reset it. Okay, hope you enjoyed this. This is Ray's magnetic torque generator number 5. If you'd like to support this work, go to Buy Me a Coffee. Have a good day inventing.